you ever be wondering why the sky is blue? How many say, well, it's probably the reflection of the water. All right, now go to Minnesota. Now go to Kansas. What's the color of the sky in Kansas? Well, it's usually a yellow-green, right? Come on, what is it, gang? It's still blue. Why is the sky blue?
It's absorbing all the red.
Little bit different phenomenon going on here. Let me just tell you about it. It turns out that light coming down from the sun, boom, showers itself upon the atmospheric molecules. Now we got big ones here, we got little ones, we got all sizes up there, okay? And these molecules will scatter off the frequencies of light. It's called scattering. Now, what frequencies will be scattered? Let me give you an example. Let's suppose I have a couple of bells here. Here's a little bell, and here's a big bell. When I disturb these things, they're going to scatter sound off in all directions, and what will the sound be, high pitch or low? Let's try the little one right here. Boom! You hear that? Now let's try the big one. Bing! Did I have that right? How many say, no, I got that wrong? Wrong? Okay. No, that's completely wrong. It turns out the little bell will bing, and the big bell bong. Isn't that true? Guess what behaves the same way up in the sky? The what? Molecule. What do you suppose the little tiny ones will ring? High frequency or low frequency? High frequency. How about great big ones? Low frequency, okay? Now, what are the size of the molecules in the sky? Large or small? Begin with an S. Small. And then nitrogen and oxygen mostly. Isn't that true? O2, N2. And when that sunlight comes beating down on those things, it scatters off. Light scatters off. And it turns out the color of the sky is the color of all those little bells, or all those little optical tuning forks, or all those little vibrators. And they're vibrating at mostly what frequencies, gang? High frequency. How many know what high frequency looks like to the human eye? Blue. And higher frequency, even violet. Let me tell you something. The sky really scatters off more violet than it does blue. But you know what? We're not so good at seeing violet. We're a lot better at seeing blue. So guess what our eyes tell us the color of the sky is? Begin with a B. You could have done that without the hint. Okay? And it's blue because the tiny particles are scattering off the high frequency. So we see a blue sky. Okay? Interesting enough? Now, you look straight up at the sun, straight up above. You see the sun white, yellowish white. Okay? Okay, a little bit of filtering coming through, but not very much. How about at sunset, gang? At sunset, when you look at the sun, it ain't white anymore. How many say, well, it's sort of like an orange, but there's probably no reason for that. It's just characteristic of sunsets and sunups to be orange. How many already see why it is that the sun is kind of orange at sunset? Let's take a look. Is the Earth here? Here you are standing right here. Here's the sun at noon. Some of that light comes down, hits the air, scatters off to your eye, and you're seeing what mostly scattered is blue. So you look up and you see blue all around. But when you look directly at the sun, that white light, boom, overwhelms the little bit of scattering going on. You see a white sun, whitish. Okay? So at noontime, boom, you see the sun whitish, huh? How about at sunset? What happens at sunset? Can we do this? We can do this experimentally. I'll tell you what. Let's just do it right here. Here's the atmosphere of the world right here. It's the atmosphere of the world, huh? No. Let's do it this way. Here's the atmosphere of the world. And here's the sun. Now the sun. Red, orange, yellow, green, blue, violet. Okay? Bring! What do you guys hear? Well, let me just do it now. I'll do it again. Red, orange, yellow, green, blue, violet. Bring! What do you guys hear? White. Do you hear white? Huh? All the frequencies together give you white. Isn't that true? Right? So you hear what? What color of the sun? Begin with a W. End with ite. Try it. White. All right? Whitish anyway, all right? White sun. All right. Here's our atmosphere down here. The atmosphere. these tuning forks. Blue, 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 violet, violet, blue, blue, red, blue, blue, pink, blue, blue, chartreuse, blue, blue. Get the idea? What's happening? I take and I ring all these. Ring. What do you guys hear? Blue. You all heard blue. That's right. Now there's a little bit of red in there, yeah? A little bit of green in it. Well, mostly what? Blue and violet, yeah? And you heard blue, yeah? Okay. Let's try the sunsets. Can I have a volunteer? Mador. Put your ear right down here. And I'm going to hit these tuning forks. No, right behind, right behind. I want it to go right there. I'm going to hit these tuning forks. This is the sun, 150,000 kilometers away, and the sunlight going to come down to the atmosphere. Boom. And Mador's standing on the ground, and here's the sky between her and the sun, yeah? Here we go. We do by experiment. One of the beauties of science is you do by experiment, huh? You don't just do it all and you hit. Here we go. Bring! Oh, first of all, I should say this. You guys get the white again. Let me put a reflector here. So all this beam energy goes down here. And this beam energy is going to scatter off here. All right? Okay. Bring! What color you guys hear? Blue. Blue. Did you hear blue? You all got it? Good. Madro, what color did you hear?
White.
Yeah, you heard. She heard white. Why'd she hear the white?
Because she's standing right next to the...
That's right, honey. Some filtering behind you. She got that coming right at her. It's a good thing you didn't have your eyes there. Oh, God. No, don't. Just get your ear there. Just get your ear, okay? You heard a white. Isn't that true? Okay, here we go. Okay, right like that. Now, we are at sunset, gang. Sunset. All right? Air is thicker. Bring! What color you guys here?
Blue.
Yellow.
Paul, would you pass out the Q-tips? Let me remind you, we got blue, 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 red, blue, blue, chartreuse, blue, blue, red, blue, blue, pink. All right? Reminder? Huh? All right. Major, put your ear right behind you. Right behind you. You can even put your eye now, it's all right. Bing! What color you guys here?
Blue.
Blue. What color are you here, Mador?
Orange.
Yeah, all right. Mador, right here. Right here, honey. Beautiful. Great. You've been a sport. Hey, is this not neat? Is this not neat? At sunset, of course you're going to see orange. Because at sunset, that light's coming through many, many, many kilometers of air. And what color is being scattered out all along? Blue. Blue is coming. All these people looking up seeing the blue sky. They're seeing the blue that you would have got to you. And by the time that light gets to you, honey, it's all tuckered out in high frequencies. Almost no high frequencies left. And so what finally gets to you, high or low? Low. And so it turns out the atmosphere is transparent to the low frequencies, but not so much to the high. The highs are scattered. And that's why you see the nice colors at sunset.